those 30,000 babies that they are growing in their hive need to be kept at 35 degrees centigrade, 24/7, every day of their lives for those 3 weeks, or they all die. So when we think of a hive as a room, as a place where bees can live, and we think, well, let's provide them with a really cool pad with, you know, there's a picture here up on Zoom of a really nice apartment with kind of furniture and staircases and a mezzanine level and all that kind of thing. It's like the bees absolutely would not thank us for this, because actually the hive is more of a womb than a room. The hive is actually more like a neonatal ward full of incubators where babies are kept at the right temperature. If they're not kept at the right temperature, they die, and the bees have an incredibly sophisticated way of keeping them warm when it's cool and keeping them cool when it's warm outside, and this is absolutely vital. And the problem with our lovely box that we provided, which was the right size and the right shape for the bees, is that its walls are 1 inch thick, and the walls of the tree are roughly 10 inches thick, and the tree is massively better insulated than our hive. So when you're having to try and work hard to keep an even temperature inside the hive for your babies, and outside the temperature is fluctuating from very hot to very cold, and the bees have got to do a ton of work to try and equalize the temperature to maintain it as a steady temperature for their kids, they will choose somewhere that will give them the best insulation, because it means the less work they have to do just to keep the temperature right for their kids. Never mind flying off to flowers and getting food and building comb and all that other kind of stuff. None of that makes any difference at all if all their kids have died. So let's have a look now at, so that's another picture of a kind of tree showing how thick the walls are. You can see if you're on Zoom, there's little bits of comb inside this cavity, and there's huge thickness of tree. And there's a picture of one of our babies wrapped up, cozy, newborn baby wrapped up in wool to keep its temperature steady. And this is what we do to help our little boxes become as good at insulating the babies for the bees, is that we wrap our hive boxes in this substance here, which is sheep's wool. For 8 million years, it's been keeping sheep at about 36 degrees centigrade. Bees need it to be about 35. Inside you and me, we are about 37. So basically inside a hive is about the same temperature that we have when we're not afflicted with coronavirus. When we're normal, healthy temperature, we're about the same temperature as the baby bees. So what I do is I make these kind of sleeves of wool to go around each box, and then I wrap the hive boxes in wool, and the wool's covered with this waterproof stuff to keep the rain off it. It's like a big Gore-Tex puffer jacket. And the bees prefer this insulated hive to the uninsulated hive. And the great thing is that this weight of wool, this thickness of wool, a double thickness of wool like this, offers the same level of insulation as this massive thickness of tree. So basically, this wool here offers the same level of insulation as all that wood, but it doesn't weigh 25 kilos. It weighs almost nothing. And the bees, when they're choosing somewhere to live, they send out scout bees, hundreds of scout bees. These bees are the oldest, most experienced, wisest bees in the colony. They've done all the jobs in the colony, from cleaning up after the kids, to fetching food, to defending the hive, to bringing out the dead, to carrying water, to bringing in pollen. They've done all the jobs. And now that they are senior bees, when the colony is looking for a new home, because they know the best things that a home will offer and to make the best choice, they are the ones that go out and they're looking for a new home for the colony. And they will check out the fact that it's a cavity or a place, you know, I don't know, in your attic or in the soffit of your house or in a chimney or ideally a tree or even better a beehive. They'll check out it's big enough for their family in the same way as we would know if you've got 6 kids, a 1-bedroom flat's not going to be big enough. Westminster Abbey, probably too big. They know what size they're looking for. They'll find a space. They like it to be up high, defendable, not too many predators. They like a south-facing entrance. They need an entrance which is small enough to defend, but big enough to allow the flight path of Heathrow air traffic coming in and out. And they will find a kind of Goldilocks size of space. But I am certain that they also check the level of insulation that's in the hive. And the reason why I know that, and they do something a bit like an energy survey that we do when we have to buy and sell properties or whatever. We find out how well insulated it is, how much it's going to cost to heat, how much work we're going to have to do to earn money to pay for the heating bill or the cooling bill if it's really hot and you've got aircon. And so I wrap my hives with this wool and some waterproof, and they become a little bit like a thermos flask, keeping the bees warm in the winter, but also the same thermos that keeps your coffee hot keeps your iced martini cold in the summer. So actually it stops the sun beating down and turning the hive into a solar oven and them, or cooking inside and needing to do lots of work to actually cool it down. And so when a swarm, the scout bees are sent out to the swarm, they're looking for somewhere new to live. They will, the reason why I'm fairly sure that they check out the insulation is because for the last 7 years, I have offered scouts on the front of my house the choice between a new home, which has got no insulation, and a new home which is insulated to the level of a tree, the kind of home, the level of insulation they would have been used to for 15 million years. And even though when swarms move in, I swap the 2 hives around and I, make it random. I've had about 10 swarms, 11 swarms move in to one or other of these 2 bait hives, one insulated, one uninsulated, and every single swarm has chosen the insulated hive, every single one. So it's clearly very important to them. They've made the choice. And the thing is, you don't have to be super clever to work out which one's the most insulated. All you have to do is visit it at different times of the day. And if it's really cold in the morning and it's quite warm inside, as you fly inside, you know it's quite well insulated. If in the middle of the day, when it gets very hot in the summer, it's still a little bit cool because it's insulated because the heat hasn't got in, then you know it's insulated. If it gets very, very hot in the afternoon in the summer and it gets very, very cold in the evening, you will then know it's about as well insulated as a tent. I don't know whether any of you have ever been to a festival and camped, but if you go into your tent at 3 o'clock in the afternoon in June to get that bar of chocolate that you left in the tent at 9 o'clock in the morning, your chocolate is liquid. Your tent is like a sauna. It's unbearable. If you had to keep a newborn baby comfortable in that tent, you'd be thinking, why didn't I live in a log cabin with really thick walls, which was better insulated, which gave me more even chance of getting down to a kind of more stable temperature. So what happened on the waterproof wrapping that I wrap around my hives is just a little bit of standard roofing fabric, and it's like waterproofs it. And it just happened to come with one word printed on it when I bought a bigger roll of it to do the hive. And that word is protect. I don't know if you can see, it's a bit chopped off here, but it's protect. And that word was just kind of accidental. in my mind, until the 14th of June 2017. And here is a view from my roof, looking west. And in the foreground of this picture, you can see one of my insulated hives clad in sheep's wool. And in the background, you can see the burnt out shell of Grenfell Tower, which was a building which had also been clad in insulation for the benefit of its occupants. And that building is now clad in a waterproof fabric, and it's got the words "forever in our hearts." And maybe if we'd concentrated on the word "protect" before 2017, June the 14th, we might not be having to say those words "forever in our hearts" for Grenfell. And the thing about it is that the scout bees, when they are going to check out somewhere that they might want their entire colony, their entire family to move into, what they do is they fly, they find somewhere, and they measure it all out like a kind of estate agent, and they find out how big it is, they find out all the details, and then they come back to the hive and they tell all the other bees about how good it is. And they tell the other bees by doing a dance, which is called the Waggle Dance. And normally this dance is used to tell the other bees where food is. There's some food in that direction, that far away, and it's a pretty good food source. And that allows the bees to share knowledge about food. But when they're looking for a new home, the scout bees come back and do a similar kind of dance, and they explain there's a really good potential home they're excited about, and it's in that direction, and it's that far away, and they say, it's great. And the other bees do not say, whoa, that's great, let's go there. What they say is they go, that's interesting, I'll go and take a look for myself. And if it sounds interesting, the scout bees will go to that place and they will measure it all up. And they will come back to the hive and they will say, yes, here's the particulars. A bit like an estate agent, a bit like preparing particulars for a new dwelling place that an estate agent would be selling you. But the really, really big difference between scout bees and estate agents is that scout bees never, ever lie. They always tell the truth. They dance the unvarnished facts. Because why would they lie? They're not on commission. They are going to have to live not only with the consequences of the decision that is made about where the colony moves to, they're going to have to live in the consequences of the decision with all their family. And I think the philosophical, political, social question that is begged by the activity of the scout bees is, if the people who had been cladding Grenfell Tower had actually been going to live in Grenfell Tower with their families, would they have been more careful? And the scout bees, when they come back and they share some details, and other bees go along and they come back and they go, yeah, that place is really pretty good. So we're kind of forming a bit of a buzz about this, but we can't do it by just clicking like or going share. Yeah, cool, man. Yeah, they have to actually get off their butts, go and check it out personally. And then what will happen is that a kind of consensus will start to form in the colony that we hear this place is good, it's all very good, very good. And then, so maybe when they're looking at 16 possible candidates for a place to live, and it will be whittled down to 2 favorite ones. And then eventually it's like the House of Commons, where there are 2 kind of opposing groups who are saying, this is the one, this is the one. And then when they're doing the dancing, they literally headbutt other dancers who are disagreeing with them to actually say, no, get off the dance floor, listen to my one. But what happens eventually is that the colony reaches a quorum and they go, you know what, enough of us all agree that we're all going to this place. And then when they've done that, they all just go. And that's when you see the swarm flying through the air like a black cloud, because what that black cloud is utter conviction because they have all democratically agreed that this is where we're going to go. There is now no more debate. There's no more argument about it. It's been assessed very thoroughly. There's been a really democratic and truthful process of scrutiny, and then the bees will move into that place that they've decided, and research has been done on this, and when they make that decision, they get the right answer. They find the best place over 95% of the time. If we had any human institution that made the right decision 95% of the time, we would be doing really well. So I think I'm just going to pause at that point and see if anyone's still awake, if anyone's got any questions. And here I am, I'm back in the room.
Thank you so much, Bill. I love the idea that the scout bees go out and the way that the hive works out exactly which is the best way forward. Can I ask you the question again I asked you before I let everyone else in on this? Coronavirus is right on our case at the moment. The bees have an understanding, innate understanding of what's best for the colony. How would they be dealing with something like coronavirus? Could they socially distance?
Well, I think the thing is that what the bees would have in common with us would be that this was a completely new experience. And so the bees are fantastically good at doing what they do and knowing what they know. I mean, you know, they make this extraordinary honeycomb, they can navigate to flowers and all this kind of thing, but they don't make pizza. And they don't make smartphones or fire engines. You know, they do what they do, and they are brilliant at it. And we still don't know how they make honeycomb, but it's extraordinary. But so I guess the most similar thing that's happened to bees recently, which would be similar to what's happened to us with coronavirus, is that this parasitic mite, the varroa mite, which was a really kind of minor parasite somewhere in Asia 40 years ago. And then we started posting bees all over the world. And these mites were, you know, sort of attached to the bees. So human beings spread this minor parasite with bees globally in 40 years. So the bees had to actually, you know, and this mite is quite devastating to bee colonies. And the bees had no idea, you know, WTF. They didn't even know the mite was there. They didn't know what it smelt like because they spent 15 million years of their lives without any mites. So something new comes along. And what's really interesting is that they have adapted their behavior in the space of about 20 years, and they've started to recognize the fact there's a problem and take action to, you know, chuck the mites out, chuck out their own larvae that are infested before they have a chance to develop. So, you know, they're learning grooming behavior. We are, one of the other things about insulating is that insulating a hive allows the humidity in the hive to remain high. Bees like high humidity. The eggs of bees thrive really well in high humidity, and bees are regulating humidity as well as temperature. And mites hate high humidity. So if you have an uninsulated hive, what you have is that you make it much more difficult for the bees to actually keep the humidity high because the walls of the hive tend to be cooler. And anybody who has had a shower in February in a bathroom that's single glazed will know that water starts running down the glass because it's condensing. Well, that water used to be in the atmosphere and keeping the humidity high. And when the cold glass of your window allows the water to condense, there's now less water in the air and the humidity falls. If that were a hive, the mites would be going, yay, lower humidity, we have a better time, the bees have a worse time. if you have double glazing in your bathroom, if your window's better insulated when you have that steamy shower in February when it's freezing cold outside, water does not condense on the glass. It stays in the air, the humidity stays high, and it disadvantages the mites and it slightly advantages the bees. So there are various things that we can do to help. But the point is that what will have happened initially is that the varroa mite just trashed the bees. The bees that didn't know what to do just got killed. I mean, it's pretty brutal. So the idea is that, the kind of herd immunity thing, it's like with bees, it's becoming like colony education. The thing about it is that if we say the bees have been around for 15 million years, I would estimate the chances the bees haven't had to deal with this kind of thing before are pretty slim. In the last 15 years, it would be really surprising if not a few parasites have tried to have a go at the bees, and the bees have gone initially, whoa, what is that? You're killing us all. And then the survivors go, we're clever, we can do it. But they do, some of that learned behavior can take a long time to evolve, but some of it can happen really, really quickly. Bees have extraordinary epigenetic responses to environmental stimuli. To give you an example, there was a really cunning experiment done in 2012 where there were nurse bees who were at home looking after the babies. And one of the jobs they do when they've graduated from being a nurse bee is they become a forager, they become a pilot, they get their pilot's license and they fly out and they collect food. So what the researchers did one day was they just, whilst all the foragers were out getting food from the flowers, they just took away all the nurse bees. And the foragers came back to the hive and saw that no one was looking after the babies. And so they reverted to being nurses. But it wasn't just they went, oh yeah, I know how to do that. I've got that behavior. They actually epigenetically changed. The methylated groups on their DNA switched on and off. And it wasn't like they just went back to behaving like nurses. They became nurses in terms of their DNA, in terms of their biology. But the really cool thing is this had to happen within an hour or two. Otherwise, the babies are going to die. So let's suppose you're a forager coming back and you are seeing that there are no babies being looked after, and you go, crap, I need to become a nurse again. You do your epigenetic DNA, you become a nurse, you start feeding the babies. But if all the foragers became nurses, then the colony would starve because there'd be no one getting in the food. So when you flew back as a forager and 49% of the foragers had become nurses, you'd be going, oh, I'm not sure whether I need to become a nurse or not. And you would remain a forager, 49, 50, 51%, whatever the need was. So this was an incredibly quick epigenetic response to an environmental catastrophe. So sometimes they can do things extraordinarily quickly, but that one is reverting to a type of behavior that they know. But here's another one which is quite interesting. When beekeepers use smoke on bees, they do it because they say, oh yeah, it calms the bees down and they don't sting me so much when they go into the hive and all this kind of thing. And we used to think, yeah, that's right, the bees are all kind of calm. And actually what we've now come to understand is that when you smoke a hive, what the bees understand from that, because they are tree dwellers, is they go, forest fire. And so what they do when they smell smoke is they go into the hive, right into the deep, and they fill up with honey. And we used to think that they were filling up with honey so they could actually organize, 60,000 bees leaving safely to go and find somewhere else to live, and to do it really quickly. So they were filling up to get some fuel to fly and escape the forest fire. And then we discovered that in order to do that logistical move, the bees didn't just use dancing and waggle dancing to communicate. They do it with pheromones, with smells. And all the smells the bees needed to do to communicate, moving, 60,000 bees who are in the middle of stuff somewhere else, all together at once. All these delicate smells that were, like communicating, were completely overpowered by smoke. They wouldn't be able to understand anything that any other bee was signaling to them with a scent. So they can't. There was no way they could organize something as massively. Can you imagine organizing 60 people on this Zoom meeting to go out and do the same thing? 60,000 bees in the middle of it all doing this. Absolutely no way. So what we've now realized is that when the bees smell smoke, what they are doing is they are going into the center of the hive to get the most protection from the insulation of the tree they think they're living in. And they hope that the fire will burn and the tree will burn, but they won't get cooked. And the reason why they're filling themselves up with honey is because if they're full of honey, they'll take longer to cook. And they've got a better chance of surviving. And once the danger's over, they put the honey back. It's not they're going, it tastes delicious. They're just going, if I eat it, I'll take twice as long before I start boiling and I'm gone. And so the interesting thing is, though, a bee lives for an average of 9 weeks. Now, there's unlikely to be a forest fire every 9 weeks. So the vast majority of bees have never experienced a forest fire. Their mum, their grandmother, their great-grandmother, their great-great-great-great-great-great have never experienced a forest fire, and yet when they smell smoke, they know exactly what to do, and they do it. So the thing is, they've got all. There are responses that they do, and you go, no one taught you how to do that because you've never seen anyone react to a forest fire because there hasn't been one for 10 years or whatever. Even in Australia, for Christ's sake, it's not every 9 weeks. So you have never seen another bee do this, and yet you all know how to do it, and you all do it kind of instantly. It's just like get into the panic room, fill yourself up. Do it. It's your best chance of survival.
Bill, that's amazing. I mean, we obviously have loads and loads to learn from the bees. I realised we got Ollie Tuck with us, who actually is only here because he thought we were talking about Brentford, but never mind. Has anyone got a question for Bill?
I try a bottle flip. I'm probably going to fail it, and that's another time.
Sorry, is that Paprika?
No, somebody, I don't know, is it Jess?
No, it's Jess. Jess, hi. How you doing?
I have an interesting question for Bill. I've been wondering for quite some time.
Jay walk in, then do side hustle.
Yeah,
Jay walk in and then do springy.
Hold on. Yeah, we good? Jess, what's your question?
Yeah, Bill, so I live in RBKC.
Yeah.
In a terrace, in a Victorian terrace, whole floor flat. Little.
We're gonna springy after.
A little front garden.
Lee?
I'm talking over people here.
No, you're not. I'm trying to get rid of whatever the background noise is.
Right. And I really want to keep bees.
We could be griefers.
Right. I've many times asked myself, could I get away with having a beehive in my little front yard of my little terraced house in Westbourne Park Road? And I was wondering if you know what the guidelines are or what I would have to do if I wanted to do that, or indeed if I could keep one on the tiny back balcony outside my bathroom window, which isn't big enough to, put a chair on really, but could probably just about take the width of a beehive.
Yeah. Okay. So it's a really great question, and I think it depends on. The answer is always yes.
Okay.
First up. Yeah, you can. Definitely. And the back balcony sounds pretty good to me. The issue really is whether you want to help the bees and or whether you want honey. Because what you can do is, what you can do is you can have, like for example, there are thousands of people in this country who have bird boxes, and almost none of them expect eggs for breakfast.
Yeah.
right? So, and then there are kind of poultry farmers who have big sheds and they make a living out of selling eggs. So, it's a question, somewhere between those two, most people land. So what you can do is on your back balcony, how high up off the ground would that be? The back balcony?
I'm whole floor at the front, but I'm actually about 30 feet off the ground at the
Oh,
back.
fantastic. Well, my bees are on my roof.
On your roof.
Yeah. I'll just, whilst we're talking, I'll just do a screen share and I'll just show you that kind of, where are we? Yeah, so there we go. So that's
exactly the sort of roof we have, but unfortunately I don't have access to it. So
yeah. Anyway, but I mean that's about the same height as that you're talking about. It's quite high, but the bees will be totally fine with that. And what you could do is, the only thing about having a very small balcony is that if you want honey, you need to be able to at least stand beside the hive and take a few boxes off and a few boxes on. You need a little bit of room to work. But if all you want to do is give a home to some bees, then you can literally put a couple of these boxes on this kind of size.
a few of those on the wall, right?
Two of those, and that is the ideal size for when scout bees. That's 40 litres, and they're going to go, whoa, Goldilocks. That's the perfect size for us. Right. And a colony may move in, they may thrive, they move out, they may die. But basically, it would be like a bird box, and you're providing a space for some bees. The really cool thing about the hive system that I use, and I've written this book, and you don't have to buy it. I mean, I know for a fact there was a copy of this book in the North Kensington Library, so you can read it for free. It's called The Idle Beekeeper. It's got, it's by me, and you can read about. It's so easy to make these boxes. Even if you can't put up a shelf, you can make these hives. And, you can get the wood cut by New Line, and you can just bang it together, and the bees will forgive you for gaps and cracks and things like that. But the really cool thing about this two-box system is, should you decide at some point, if you start off with a bee box, you say, I don't want any honey, and some bees. Should you decide, actually, it's delicious and I quite like some, then what you can do is you can just start adding boxes. And basically you can move from a bee box into a hive that you can take honey from and back again. Should you just start with a hive where you go, with this system where you go, no, I really want some honey, and then you go, actually, I can't be asked anymore, or I just, I don't want to interfere with them, or I feel bad about stealing their honey. And also, not every year do they make enough spare that you can take honey without killing them, making them starve over them. I mean, honey is just their winter fuel. It's what they need to get through the winter.
Do you have any views about, if I was going to have a beehive for harvesting honey, like a proper beehive, so I think there might just about be room at the gap at the end. Yeah.
Okay.
Do you have any views about what sort of hive? Do you have any thoughts on those hives that are meant to let you harvest the honey without opening the hive?
Yeah. I think, the flow hive. Okay, so the flow hive, the hive that I use is, really kind of simple. It's kind of boxes. It's very low intervention. It's the closest thing you get for a bee to living in the wild. I mean, and when you harvest honey from it, basically it takes about half an hour on one occasion per year.
Right.
And that's your work. I've estimated in my book that you disturb the bees for 1 minute a year if you want to take something from them. Now, the thing about the flow hive is that in theory, you're siphoning the honey away and the bees don't know that you're doing it. A bit like hedge fund managers. You know what I mean? So basically, it means you have no contact with the bees face to face. You're just kind of sneakily, creaming off a little bit of honey. And not only that, but the mechanism of it. I mean, to be able to build a hive like mine, you don't need any carpentry skills whatsoever.
Right.
Anyone can knock it up. It was devised by a French guy who called it the People's Hive because he thought that everyone should be able to make it. Everyone should be able to have one. It should be utterly democratic. Most hives that people use are framed hives. They're Nationals or Langstroths or whatever. They're the ones with the traditional frames that you pull out and you look at the bees and you inspect and you manipulate and you stop the queen from going where she's going and you pour in chemicals. And this is like, basically it's like, who's the guy, Turkey Twizzlers?
Bernard Matthews.
Bernard Matthews, exactly. It's a bit like if you wanted to have a turkey, just one turkey for Christmas, do you go to Bernard Matthews and check out his gear and check out his antibiotics and go, that's how I'm going to keep my bees? You don't need to. So, but even, so most beekeeping is Langstroth or National. That's the frames. And that is how honey is produced. Bee farming is done. That's the sort of equivalent of the Bernard Matthews thing. And that's become so prevalent that everyone thinks that's the only way to do it. And it's not the only way to do it. And also to be able to make one of those hives, you'd need to be a cabinet maker. Each of those boxes has got 11 frames in it that slide in. It's like a chest of drawers with 11 drawers that all fit in beautifully without sticking. Now, I can't do that. It's very complicated. When you come to the flow hive is not cabinet maker. The flow hive is watchmaker, because you have cogs, you have levers, you have cams, you have bits of plastic honeycomb that open up and then let the honey drain out and then come back together again. And, quite frankly, I think it's, early days for the flow hive. I could be proved wrong, but I'd like to see how efficient one of your flow hives is 10 years after you bought it. And it is 10 to 20 times more expensive to buy.
They are expensive, aren't
They're really expensive. And so, it's a bit like, and I think that it is the really crucial thing for me about beekeeping is it gives you a dog in the fight in the environment. So when you start keeping bees, the really surprising thing I found was that you suddenly start to notice where their food might be and what the weather is and what's going on around you and whether it's a cold spring or a hot spring. And actually suddenly, because you've got a wild living thing that you are caring for, but they are wild, but you're caring for them and you're trying to provide them with a home and try and keep them alive. Suddenly, everything that's going on the planet is in much sharper focus. My suspicion is that if you are going to be sneaking up to a flow hive and turning a tap and getting honey, then you're not really going to be interfacing with the environment to the same extent or caring so much.
Yeah.
And as someone said, if you want a lot of honey, make friends with the beekeeper. You know what I mean? So why go through all the crap of actually doing it and getting, stung and dirty and, whatever, and disappointed? And if all you want is honey, then, buy really good stuff or become friends with a local beekeeper and you can get all the honey you like. But actually, so I think what it does, it distances you from your relationship with the bees because
that makes sense.
And so
one last question,
yeah.
quickly. Are you familiar with the Bee Lectures by Steiner and his notion? I understand, I've skimmed through them, I haven't really read them properly, but I understand that he predicted the mites and the parasitic blights that have affected the bees, and his thesis was that this was something that was going to happen inevitably as a result of the industrialization of honey production.
Yeah, and I think actually, no, I have, and I think it's not so much the honey, well, it's a side effect of honey production. What it is that in order to sustain this, vast industrial honey machine, it's only workable because of colony losses, because the bees don't thrive, the queens keep dying. So the queens have to be replaced. And that means that there are specialized queen breeders who, when your queen dies, you go, hey, my queen's just died. And they go, courier, DH, whatever, we'll have a queen in 24 hours, and you get a new queen, and it's like, you know, the queen is dead, long live the queen, and we send you a new queen. Okay, so they breed queens.
So sorry, Bill. We haven't got. We've got 8 minutes left. We do have a question coming in from Ollie Tuck. Ollie, you were a friend of Bill's during the Saving North Kent Library.
I wasn't involved, but I know that library. I know I've been on the roof of the KPH pub, which I think is a great spot for a hive too.
Yeah.
I wonder if Bill knows about. Do you know that, Bill? On the corner.
Yeah, no, I know the pub on the corner. It's literally 100 yards from where I live, and so actually for me, that's a bit too close to my bees to, you know, any hives there would.
If the colonies are too close, would they ruck and not help each other?
No, it's not. No, it's not so much that.
Like QPR and Chelsea.
What's interesting is that they don't help each other. It's like I've got 6 and they're, you know, a foot apart, and when they fly into the hive with pollen, you can tell the flowers they've been visiting because of the colour of the pollen on their hind legs. And what you can find is that 2 hives with the entrances this far apart are bringing in completely different colours of pollen. And what that means is that the hive is sharing intelligence about where these flowers are within itself, but not with the other hive.
Paul?
So, these 2, so basically the bees go out, they find flowers, they come home, they say, "Oi mate, there's great," and the bees go out there, and the same thing's happening next door, but not necessarily the same flowers. So they won't ruck about food supply. They will try and rob. You know, basically, they'll if they can get into the other hive and nick a bit of honey, they'll do that. So it's quite elaborate growth.
I do some voluntary work at the Grenfell Memorial Garden.
Yeah.
And so if the flower's in the flower bed there, you probably know it, you pass it by the maxilla there.
Yeah.
You could see if your bees came from there, if you check their legs.
Yeah, well, you could check. I can't tell which flower, but I can tell which species of flower. So basically,
remarkable.
Yeah, because what they do is, and the reason why you can tell what species of flower it is, and the reason why honeybees are actually super pollinators, is that the honeybees, when they're gathering pollen, they kind of cram it into these kind of hairs on the back of their legs, which is like a basket. And I'll just show the fact that when every flower has different. Yeah, here we go. There's some examples of pollen grains. So on the bottom there, whoops. Yeah,
that does look like Corona, by the way.
Yeah, okay, so on the bottom is that's pollen from one species of plant, and they're all the same shape. And the ones up above are from different species, and each species has got a different shape of pollen. And what the bees discovered was that when they go out on a flight, if they stick to the same flower, they can actually, because the lumps of pollen are the same shape and size, if they stick to one flower, they can pack more pollen in. It's a bit like doing a supermarket dash, and you just put tins of beans into your trolley, nothing but tins of beans, into your car, and then you do cabbages, and then you do loaves of bread, and you can actually get more in that way. So the bees worked out that if they stick to the same flowers when they go on an outing, they can actually get more pollen in. And what's really brilliant about that for the plant is that when a bee arrives, if it's doing a lavender flight, what it means is it's only going to visit lavender flowers, which means that every time it touches a lavender flower, it turns up with sexually viable pollen. Because if it was just standing around and doing lavender and lobelia and laburnum, and actually
the
laburnum pollen doesn't do it for the lavender, only lavender pollen. So basically the bees are like these kind of plant pollen sex gods. Yeah, you see. So because of that, you can tell when they fly back into the hive, you know with a honeybee that it's only been to one species of plant on that flight. Whereas other pollinators, I mean, wasps do pollinating, but they don't, as far as they're concerned, food's food. They don't care where they go, any old plant. So, and the point is that when they bring the wrong kind of pollen to the plant doesn't get to have sex. And the only reason the plant produced that pollen was to have sex.
I'm almost worried that we put this on before the watershed now. Now I see we have Ed Daffard with us. Hi,
Hey,
Ed. Hey.
Ed, Super Ed.
How you doing, Ed? Now,
Good,
Ed,
thank you.
Ed,
Very
as you
great,
probably,
Ed,
as you
Hi
know,
there.
Ed's a great birder, and we've always heard about the birds and the.
Yes. Yeah.
Um,
Morning chorus.
don't birds eat bees? Or
Yeah, they do, and that's kind of fine, except when it's fine. That they will, the birds will get probably the weakest bees. They'll fly them, the ones that can't escape when they're flying. But where it becomes really tricky is when the bees are, when those scout bees have decided that we're all going to go to this place democratically, and then 25,000 bees all go. Okay, so in the middle of those 25,000 bees is one very special bee, who is the queen bee, who is the only bee that can have any babies. Anything happens to her, it's all kaput. Those 25,000 bees are going to die straight away. They've got no queen. It's all over. They can't exist by themselves. They can't exist without her. And she is slightly bigger than all the other bees. So if you're a bird, she's the best snack. And so there will be a kind of CIA entourage of sort of, Navy SEAL security around the queen in the middle of that cloud of bees doing the big flight, trying to protect her as much as possible. But if she gets eaten by a bird, then that's it. That's really only when birds are a problem. That and woodpeckers pecking into hives to eat the honey and the babies.
Bill, I've got to stop you. Thank you so much for this. We can carry on Zoom for a little while longer.
Okay.
I'd like to say goodbye to everyone who's listening in on portobelloradio.com. We've had some people from all around the world listening to that, which is fantastic. People from Glasgow, Southaven, United States, Hamburg in Germany. Bill, thanks for coming and being the very first Portobello Radio lecture, Portobello Hive lecture. Thanks to members of the Hive for turning up to support this, and I hope we can carry on. Thank you for Ollie Tuck. I know you thought this was something to do with Brentford, but you asked a fabulous question.
Oh, do behive. Behive yourself.
Behive yourself. Goodbye, Portobello Radio. Craig, well, we're going to lose you. But back to the Zoom. Bill, anyone else got a question for Bill?
I'd like to ask.
Africa.
Yeah, just, guys, because we are in the middle of this virus thing and also the conspiracy around the various radiation, and are they capable of be a warning for us? Obviously, they are susceptible to pesticides, and they, we can say when there is unhealthy stuff around, then they will show us. But how about this radiation? Are they sensitive to it?
This is really interesting, and there is a German bee scientist called Jürgen Tautz, who is, a professor, churns out peer-reviewed papers, is really, really academic, orthodox, smart, and everything. Now, he basically pointed out that he went back and looked through history, medieval manuscripts, and as far back as he could, and way before pesticides, monoculture, 2G, 3G, 4G, 5G, there were these periods where people would say, they'd call them an evaporation of the bees. The bees would all die. The bees would all go. It would be really catastrophic. And he's saying, look, what we can say for sure is that this phenomenon is not new. It predates glyphosate. It predates, BT toxins. It predates neonicotinoids. It predates all of that, there's been these absolute catastrophes. And he then, as a, you know, very respected academic with a reputation to preserve, said that whilst he completely knows that association is not causation, he says that on an absolute rule of, you know, rule of thumb, finger in the wind, if you look back at the dates as accurately as he can, when these massive bee death, evaporation, collapse events occurred, they synchronize with massive solar activity. So, which means massive amounts of radiation, not 5G masts or whatever, the kind of radiation which can, you know, fry all the computers on Earth and, you know, set power lines on fire and things like that. So they are clearly sensitive to that. They have extraordinary navigational abilities, and if those are interfered with, then they can't collect food. And if you can't collect food, you can't survive. I think that, but the other thing is that bees always, someone else also pointed out that if you look back at 1835 and look back at, there's someone saying, well, I had 17 colonies and then I had the next year, after that winter, I had 3. After that winter, I had 25. After that winter, I had 40. After that winter, I had 2, they all died. So the fact that bees don't make it through the winter is not uncommon. And they are, you know, they come back. They, you know, in the summer, it's fecund, there's food, they you know, they mate, they make increase, they swarm. The thing about swarms is a swarm is one colony becoming 2 colonies. It's how that they reproduce. You know, a bee colony is like a superorganism with individual bees, a bit like individual cells in our body, individual job functions that big groups of bees do, a bit like organs in our body. And so, and if you look at the bee, even though the queen's, you know, laying her own body weight in eggs, you know, 2,000 a day in the height of summer, and you think, well, that's a lot of babies. As a superorganism, as a colony, it tends to have 1 offspring a year. It tends to swarm once a year, like us, you know. So as a superorganism, it behaves a bit like a mammal, and they do recover and come back, and, you know, and their populations, you know, they do this. And, you know, they're still here. 15 million years on, they're still here, which is kind of amazing.
Big up to the bees. Junior, did I see you had a question? Hold on. This is my fault. I haven't unmuted you. Junior, fire away.
Yeah, my question here is, what makes Manuka honey so damn expensive?
Yeah. Okay. This is a really good question. What makes it so expensive? Like most things that are really expensive, is hype and scarcity. And then we have counterfeit as well. But here's the thing. There was a Cardiff University did a study whereby they analysed lots of local honey, see if anything was, you know, anything like as good at Manuka in terms of its medicinal healing kind of properties. And they found that there were 2 beekeepers who had some hives that were producing honey which was way more potent than Manuka. And what they were really excited by this. So what they thought was that apparently all the flowers in Wales have had their DNA barcoded. So what they, from the pollen. And so inside honey, there is always really tiny amounts of pollen. So what they thought all they needed to do was work out what was the pollen in this magical honey that they were getting samples of locally. And they would be able to then grow those flowers in Wales and have, you know, super Welsh honey, even better than Manuka. And they had plans to carpet the roof of the St David shopping centre in Cardiff, whatever plant it was going to be. And then they were disappointed to discover, first off, that although one of the hives was from a druid near Aberystwyth, the other hive wasn't even in Wales, it was in Southampton. So that was a bit of a blow. And the second blow was that it was nothing to do with the pollen. It was the thing that these two samples of honey had in common was the kind of hive that was being used. And it's the kind of hive that I use. So basically, the big difference between the honey that comes out of the hive that I use and the hive that, you know, you get most of your honey from is that in my hive, the honey is stored in a cell, one of those hexagonal wax cells. It's stored in one of those cells that used to be a kid's bedroom. So, you know, it's got all the detritus that a kid was locked in this bedroom for 3 weeks. But when the kid grew up and moved out, the bees cleaned that cell out for maybe another kid to move in, or maybe to store a bit of pollen and eventually to store a bit of honey. But what they do is, because they don't want their honey to taste of baby poo, because there's a bit of that going on when the baby's in there for 3 months, they scrape it all out and then they line the inside of it with this stuff called propolis. And propolis is like medicinal plant resins they gather from buds and leaves, and they turbocharge it with some enzymes of their own. It's kind of like a brown, kind of sticky, pungent, phenolic smelling kind of...
So is that what gives the honey its colour?
It's what gives dark honey its colour. So look, if I show you this bit of comb here, you can see that this bit, this side of it, has been propolized a lot. And this bit here has hardly been propolized at all. And that's because that bit hasn't been used as a kid's bedroom. And when you buy most honey in the UK and the world, it has been stored inside the hive in a place where no kids have ever been allowed to be. A special kid-free zone where the queen can't have any babies there. And so this honey hasn't been stored in this medicinal stuff. So a bit like when you're making whiskey, you make spirit and you put it inside an old sherry barrel. It goes in here, comes out brown. And
what's it? Oh, good grief! Sanitized and not as clean.
Exactly. But what this dark brown stuff? It's not dirt. It's medicinal plant things. So it's antiviral, antifungal, antiseptic, blah blah blah. So and this stuff. It's the propolis that actually makes the honey stored in here more powerful than Manuka. Manuka is a plant, you know, I don't know, in New Zealand, China, Australia, Antipodean, and it does produce highly medicinal honey. That's probably just because there's more of the same chemicals that are in the honey in the hive when it's the bees have been collecting stuff from the Manuka plant.
Thank you.
Brilliant, Bill. Now, Bill, I noticed that we've got Dylan with us. Dylan is the one who's charged with building the Portobello Pavilion every year on behalf of the Hive. Have you got any advice for him in terms of building a pop-up art school in Powys Square that we could learn from the bees? Hexagonals, I imagine.
Hexagonals, yeah. I mean, I think that, you know, that is, you know, just an extraordinary piece of architecture, actually, rather than art, because honeycomb is the least amount of material to store the most amount of stuff with the greatest strength. So if we go back and have a look at the comb, oops,
So looking at those structural illustrations of the
Yeah.
I think that was quite interesting. What's really good is that they use that structure as for aircraft to sort of in between the sheets of aircraft in the 50s.
Yeah.
When there was
So,
things like the first jet engines, they used that to reinforce the aluminium.
yeah. Well, it's the most lightweight and strong structure. If you look on the right-hand side of this illustration, if we're all on Zoom now, you can see that that's actually a drawing of looking down into the comb, and you can see these kind of Mercedes triangles. And what it is that that is the other side. The comb's two-sided, these things here are actually, don't know if you can see me doing a band.
Yeah, we can.
On the other side, this is where the hexagons go. And what that means is that they actually use triangular structure to strengthen each other up. And that's all occurring at this juncture here between the two sides of the comb. And you can see that the comb is actually tilted slightly upwards, and that is to prevent things falling out. Simple as that. If you're keeping babies in there, and they use the comb as to make honey from nectar, you have to distill it. So nectar is this like sugary water that comes from plants, and it's got 20% water. Or it varies depending on the plant and the time of day, but at that concentration, it's absolutely delicious for bacteria and yeasts and fungi. And so in order to kind of keep it, the bees have to distill it, evaporate water off till the sugar concentration becomes so great that bacteria, fungi and yeast actually can't survive in it. And we use the same thing when we make jam. Yeah. If you are boiling up jam and boiling water off and making the sugar concentration go, if you don't get the concentration of sugar high enough and there's too much water, your jam starts to ferment or go moldy. So what the bees do is that when they're making honey, they use these cells a bit like a kind of tumble dryer. They pour nectar into it and then they thrash it around with their tongues, and warm air rising from the nursery where the babies are being kept warm actually evaporates the water off. So they use it not only to raise kids, not only to store pollen and honey, but also as a distillery.
You know, really, rather oddly, that reminds me of the East Stand at Chelsea, which Nigel Coates once made a documentary about. But in the great vanities of the 70s architectural revolution, they made the stand in such a way that all the seats were supposed to be heated from below, from the overcapacity from the kitchen. So the kitchens create a lot of heat to make all the food, and that was going to blow out from underneath our feet.
Yeah.
But obviously, in the way of all the grand projet of the 70s, it didn't quite work.
Yeah. Well, this is like in the old days where peasant farmers used to sleep in the eaves of other animals in the winter and let the heat from their animals come up and keep them warm, and they slept up on the top. And it's just extraordinary efficiency. And because when they're constructing, they hang in a kind of literal chain, so that if you imagine that each link of this chain is a bee, they will form a chain like this, and then they will build directly above their heads, and it's like incredibly accurate, this kind of plumb vertical thing, because it's like if you shut your eyes. If everyone shuts their eyes, and what I'd like you to do is, with your eyes shut, I'd like you to lean 12 degrees to your left. Okay? So shut your eyes and lean 12 degrees to your left. Okay? Now come back up, and now I'd like you to lean 14.37 degrees to your right. Okay? Now come back up. Okay. Which position did you feel you got accurately?
The 12.
14.3.
No, you didn't. The only one you understood was straight up. You know, we all know what it feels like to be straight up. You know what your organs feel like when they're hanging. So basically, if you're a bee hanging in space, you know what it feels like. And all you need to do is build above your head. You know what that feels like. And so the whole thing will be completely plumb. It's kind of extraordinary construction.
Fantastic. Dylan,
What's the
Dylan, have you got
secret?
any, Dylan, have you taken any inspiration from that?
Yeah, I was just thinking about like what the sequence is of how they would start on making that complex structure.
I mean, do you know what's really interesting is that we thought there was a paper came out of Cardiff again. Cardiff have been churning out all this kind of bee research. I think it was 2013, and they went, the thing is that bees don't actually build hexagons. What they do, which is really easy, is they just build a tube around their body that fits around their body. That's simple enough. You just build around yourself, like building a sleeping bag, and then because they build lots of tubes together. And they're warm because they've manipulated the wax. They warm them up a little bit further, and then surface tension pulls them all together into hexagons. And you can see this for yourself. If you have a bath with some bubble bath and you make some circular bubbles on the surface and you squish them in against the wall under the pressure, they form hexagons, perfect hexagons. And then everyone thought, oh my God, that's amazing, that's really clever. Only someone then measured the temperature during comb building, and there was never a time when the bees warmed up the wax enough for it to actually be malleable, to be squished. And then also the wasp lovers went, actually, hang on a minute, wasps make perfectly hexagonal cells out of paper, and try melting paper. Doesn't happen. Ray Bradbury, for Fahrenheit 451, it just burns. So basically, we still actually don't know, but the one thing which is really, really cool is that when a bee squishes those 8 tiny segments of wax out of its body, and it mushes them together into a ball with bits of saliva and enzyme. And it turns up at the construction site of comb. The average time it spends actually building comb is 30 seconds. It turns up, has a quick look around and goes, where are we? And it goes, okay, I can do this bit here, 30 seconds. And it moves the construction forward by 30 seconds worth of work. What that means is that every bee that is doing the building can turn up, and at whatever stage the construction is, it knows how to move it forwards by 30 seconds, which means that every single bee with a brain the size of a grain of salt knows how to build an entire comb structure. Otherwise, they couldn't do a 30-second thing. There are no architects, there are no plans, there are no overseers. They turn up and they know what to do.
Sounds like the Portobello Pavilion.
Sounds like the Portobello Panto. Not.
Bill, you were talking earlier about the queen bees that get ordered in commercial.
Yes. The Steiner thing. So what happens is that in the wild is this: when a colony does that division thing and swarms, the old queen, the original queen, leaves with half the bees, and she leaves. It's like leaving the house to the kids with all the food and the furniture and the carpets and all this kind of thing, and a working staff and all this thing. So basically, what's happening is that the colony, not the queen, not the original queen, the colony pick around about 10 eggs. Out of 1,500, 2,000 a day. Every day they pick one, and they put that egg in a slightly bigger, not a normal sized hexagon cell. They make a special bigger one, and they feed that egg a diet a little bit richer in royal jelly than all the other bees. All the other bees get some royal jelly, but by feeding this specially selected egg a higher concentration of royal jelly, that egg will develop into a virgin queen. But what the colony does is that every day for 10 days, it picks an egg and puts it out. So there are 10 potential queens, or roughly 10
It's a bit like the X Factor. It just
Like the X
eliminates.
Factor. So what happens is that when these queens hatch, the first thing, they're all sisters, the first thing they try and do is kill all their sisters. Ideally, before they've even hatched, the first one that hatches will come out and she'll go, right, where's the bloody queen cell? And they try and sting through the wax and kill their sister.
Can queens sting without killing themselves?
Yeah. Well, the thing is that bees only kill themselves when they sting us. Our skin is an anomaly. They have a barb on their sting, which is designed to get through the exoskeleton plates of other insects. So they can sting multiple times other insects. And the barb lifts up the plate, lets them get into the soft bit and sting and come out again. Whereas with our squidgy skin, the barb goes in and gets stuck, and then when they fly off, it's curtains. So they don't know they're going to die when they sting. They just think I'll sting them. No, and then they suddenly discover they've been eviscerated. But they can sting multiple times other insects, other queens. But so only one queen is going to survive out of the 10. Some of them, some of the 9 who aren't going to survive might leave with a small number of bees if they can. But at the end of the queen hatching kind of thing, there is only one left. That queen then goes off on a mating flight, and she mates. She has a day where she shags as many males as she can. Comes back into the hive, sex over. All she's doing now is giving birth. That's all she does. The point is, so basically, out of 10 queens that the hive select, so the workers actually pick an egg a day and they go, this one looks quite good. They're not going to pick something shit. They're going to pick the best. They handle 2,000 eggs a day, these nurses. They probably know a good one when they feel it. They then select, so they select, selection is done by bees. They select from 20,000 eggs, they select 10. From 15,000 eggs, they select 10. Those are nourished up to queenhood. Out of that 10, 1 survives. The bees knew the criteria whereby they picked those 10 eggs, and 1 survived. When you're, that's how it is in nature.
Does it ever happen that no queen survived? The carnage is so awful that everyone ends up dead.
That maybe. I think that that would not be a good evolutionary strategy. I think that would be by accident. Normally, what happens is that you do get a couple of the 10 going, discretion is the better part of valor. I'm out of here. I stand some kind of a chance if I basically do a kind of mini swarm with a few retainers. But crucially,
one other question as well.
I'm quite answering because the Steiner, what he's talking about.
I know.
When you're a queen breeder, what you do is basically you have artificial cups that are the size of a queen cell, right. And you put an egg. You take an egg out of a cell and put it in the queen cell, and you fool the bees into thinking that this is a queen cell in the hive. You put it in the hive, and the bees then raise it as a queen. And here's the thing. One, right. On what grounds, as a bee breeder, do you choose the eggs? They're the size of, smaller than a grain of rice. They just look white. You've got no idea. So you're just picking them randomly. And then secondly, when 10 of those eggs hatch as queens, do you let them kill 9 of them? No. You want to sell all 10. So you make sure that they all survive and you sell all 10, which means that even if you had the genius to select the 10 best eggs, which you don't, you're selling 9 queens, which in nature would never have survived. And they are then breeding and the stock comes from them. So what Steiner was talking about really was queen breeding as a part of industrial beekeeping, actually depleting the natural vigor of the stock.
So you just don't get as good queens.
You just don't get as good queens because they haven't, because 9 queens that would never have made it because they weren't strong enough to defeat their sister get the chance to have thousands and thousands and thousands of kids and more queens and et cetera, et cetera. And so basically you're kind of breeding in weakness.
And that breeding cycle that you were talking about, so I mean, that makes perfect sense. It's quite obvious, actually. It seems a lot less mystical now. But that that breeding cycle that you spoke of with the queen, where she goes out and shags everything for a day and then comes back and lays eggs, will she only do one cycle of that in her lifespan, or will she do that more than once?
Well, she'll do it once, and basically she comes back. It's quite cool. She flies out of the hive with again a little entourage, security entourage. She's really vulnerable to being eaten by a bird at that point, because it's a sort of, there's not 25,000 bees around, it's just a few hundred. And then she flies to these places called drone congregation areas, which are imaginatively titled because it's where drones hang out. It's where the boys hang out. They're just places in the sky where the boys hang out. We don't know why it is, but there's lots of them. And she'll fly into this area in the sky, volume of male bees, and she'll fly through them and upwards as fast as she possibly can, you know, reeking of sex hormones. And she only lets the fastest and the best flying males catch her, and they mate on the wing, and as soon as they've delivered, she snaps them off, and they fall to the ground dead, and she's up for the next one. I've never heard it, but apparently you can hear the snap from the ground as their penis is snapped off. And then when she comes back, when she comes back to the hive after a successful,
does she take trophies?
Yeah, when she comes back to the hive after a successful mating, the last male's genitals are still hanging out of her abdomen, like Bunting by Hieronymus Bosch. Yeah. It was a good trip. But here's the thing: she then, all the sperm that she's accepted, she stores in she stores it in a sperm bladder, and then basically, as she lays each egg, she decides, or it's decided whether it will be fertilized at the point of laying. So basically, if she doesn't fertilize it, it will be a male. And if she does fertilize it, it will be a female. The interesting thing is, although she actually, you know, adds sperm or doesn't add the sperm, it's not her who decides the numbers of males and females. It's the colony. The colony say, "Oi, Your Majesty, we need more girls. Oi,
we need more workers,
more boys." Yeah, exactly. So actually, and so she is literally, she has bees feeding her at one end, and at the other end, she's laying eggs. She is literally like a protein converter. Because basically, if you are laying your body weight in eggs every day, that means you need to eat more than your body weight every day. Otherwise, you start disappearing. So
that is totally unreal.
Incredible.
Are the females the nurses and the males are the workers?
No, the males do nothing. It's a perfect society. The males do nothing.
The males are just waiting to get a shag. But what's actually quite interesting about the males is that, you know, they're big and lazy and they drink a lot, and they've got a big penis, massive penis. It's like a kind of lunar landing module thing that kind of comes out like something out of Star Trek. But here's the thing: because when the queen lays an egg and doesn't fertilize it, it becomes a boy. The only DNA that boy has is its mum's, and when that boy gets to shag another queen, in its sperm, what it's delivering is not male DNA, it's delivering its mum's DNA.
So you could say in a way that every male bee is Jesus.
Kind of. Or you could say there's actually no such thing as male DNA in bees.
So if
female.
If bees got married, the female bee would definitely not take the male's surname.
No.
Because the male's surname is pointless.
Oh, this is it. Right.
Because as far as she's concerned, that male bee is its mum.
It's the first one.
Male bee's DNA is the only genetic information it has is from its mum.
Oh, they're all
Is that
beautiful.
why? Is that why a queen? Is that why a queen will only ever do one mating flight?
No, it's just because when she goes on a mating flight, it's really risky. So the
Super
idea
practical, yeah.
so you just literally mate as quickly as possible, then back to the safety of the hive and lay the eggs. So rather
And
than,
what happens? What
Otherwise,
happens
the
if
bees
does
will get you.
picked off in that flight?
sorry,
Busy bee, busy bee.
What happens if the queen does get picked off in that flight?
then the colony is dead.
Right.
Oof.
I have a question.
That's jeopardy.
They ask a
That's
question.
jeopardy.
They can. The thing is, the colony sometimes can raise a new queen, but because so some of the worker bees can lay eggs in extremis, but the eggs that they lay will all be boys. And the point about boys,
They'll all be boys.
they'll all be boys because they're not fertilized. They're unfertilized eggs.
Man,
If the queen dies and one of the workers, with one of her half sisters, takes over, they can lay, but they can only lay boys. But those boys are the mum's DNA going out into the world. They're like a kind of genetic message in a bottle from a sinking ship. So basically, mum's DNA will get out there, shagged into some other queen, and carry on. But it won't be the queen doing it with this colony in the next.
How does a queen's life cycle end?
Well, usually it just wears out. I mean, the equivalent of giving birth to your own body weight every day, if you're a human, giving birth to 8-pound healthy babies is 14 babies a day. So if you were giving birth to 14 babies a day, firstly, respect. Secondly, I wouldn't be surprised if you were really shagged out quite quickly. Anyways, you know, so
Bill,
phenomenal.
And a question about royal jelly.
Yeah,
So I know that you can buy royal jelly in the health food store or whatever.
yeah.
How is that harvested separately to honey?
I have no idea. I can't imagine that it is harvested in a kind way, and also I can't imagine that it will do humans any good at all. I think eating a bit more royal jelly is not going to turn me into Prince Charles, or
Not that you'd want that.
not that I want that, but also I think that it clearly it's got all kinds of hormonal triggering information, which if you're a bee larvae, make a big difference. I think if it's going into my human stomach and being churned up with a lot of hydrochloric acid and all that kind of crap, it's you know, I would rather sell people wallpaper paste and say it was bee jelly and let the placebo effect take its course than actually hurt the bees.
Right. Yeah.
Myself.
Bill, that we can believe. Bill, Bill Anderson, the Idle Beekeeper, thank you so much. Thank you so much to everyone who joined us on this show tonight. Hopefully there'll be loads more of these to come, both from Portobello Radio and from the Portobello Hive.
I'll be high.
Yeah.
I'll be high.
I have a question very quickly. Do I have time?
Ilaria, of course, we always have time for a question from
No,
you.
one of this thing that 9 out of 10 bees would have not survived, a long time ago. Could this be like also why all those bees are dying? Could it be because they're getting weaker as a species?
Yeah, I think that because we are inheriting queens now that would have been, which natural selection would have never allowed to breed. That our stock of bees is weaker, except that people say, oh, there are no wild bees. They're all, farmed bees, industrial bees. There are lots of wild bees. And when after the Second World War, there was this disease called Isle of Wight disease, and it was supposed to kill off all the local bees in the UK, and Italian bees were brought in, and the local bees were smaller and slightly darker, referred to as the black bee, the native bee, and it was, better equipped to deal with colder winters and rain and short flowering seasons and all that kind of stuff. And they said, oh, they've all died out. We started doing DNA analysis of bees, and there's huge amounts of genetic DNA from those original native bees. So, there are wild bees all over the shop, and they will be naturally selecting queens. And so, in spite, I would imagine that if we stopped queen breeding tomorrow, if coronavirus, stopped queen breeding, nature would repopulate with, self-selecting fit queens really fast. Because they survive better, and then, there would be better surviving queens fighting each other to survive better, and you'd have an upward curve in terms of strength rather than a kind of downward one. And I think with the way that we farm, plants are more susceptible to insects and disease because they're just weaker, because the soil is weaker. So any kind of weakness starts to manifest itself in many, many ways, such as general health and population survivability and things like that.
Can I just say, I've got to go, but that's brilliant, Paul Anderson. Fantastic.
Thank you, guys.
Fantastic.
Bill Anderson.
You know a lot.
Yeah.
More than Michael Caine.
It's all in that book, and you can read it in the library.
I will. I will. So I will.
Hello.
Also,
Queens Park Rangers FC. Hey,
if you go onto the Idler website, there's Bill's recent blog about the bees and insulation there, with a fantastic picture of you, Bill, actually clambering on your roof during storm, whichever it was.
Yeah, putting up the scaffolding to lash the hives down to the roof.
Yeah. Man, it takes the safety of his bees seriously. Thanks very much on behalf of Portobello Pavilion and Portobello Radio. Thanks for coming. Big thanks to Bill Anderson and everyone who joined.
Thanks, guys.
Thank you.
See you.
Good night. God bless. Stay safe.